Okay, in this problem number 1, we're supposed to use the laws of logarithms that we talked about in class. And remember, there was the product rule, the quotient rule, and the power to a power, okay? So this one actually involves 2 of those rules. First of all, what they're wanting us to do, sometimes instead of saying it the way they said it, they might say expand the log. Okay, that might be one way they might have worded these instructions instead of the way they did. And what they're wanting you to do is to break this apart into its little pieces. So first of all, if you've got a log and you've got 2 things multiplied together, we have m to the 6 multiplied by n cubed. One thing you can do is rewrite it as separate logs. I could say, well, since that's 2 things multiplied together, I keep the same base, log 2, and I say that if you remember from the last problem we did, number 31 on 10.4, what you do is if they're multiplied together, you can split them apart and say it's log 2 m6 plus log 2 n cubed. And that seems a little weird, but the reason that happens, if we remember, is because we're kind of thinking about rules of exponents. When you multiply things with exponents, you actually add the exponents, and so a log is an exponent. So that's why the rule is the way it is. Now that's one rule. That was the product rule we just used. Well, there's another rule that says if you've got an exponent sitting up here, you can drop it out front. And that's like the power rule, okay? So what I can do on this now, if I want to simplify them, is put the 6 out front and say that's 6 log 2 times m plus, I'm going to do a similar thing over on this other one. This exponent of 3 can be dropped out front, and that will become 3 log 2 of n. And that's what they're wanting you to do there, is split it up that way. Yeah, okay, so that's all we got to do there. We'll look at another one. Let's look at number 3. Okay, you have log 2, and again, it could be any little base there. It doesn't have to be a 2. It could be anything. M times the square root of n. Okay, first of all, there's 2 things multiplied by each other, m and square root of n. So let's break them up. We can say, well, we can write that as log 2m. We can give each their own log and add them together, plus log 2 of square root of n. Now that would be it, except for square root of n. If you remember, with a radical like that square root, what I can do is change that. Can I also write that as n to the 1/2 power? So see how we kind of tend to use radicals, we tend to use them more in algebra as fractional exponents. And so we're going to think to change that to a fractional exponent. And now that we've got an exponent up here, remember that can be dropped out front. So once I rewrite it, I see that I can drop it out front. So you really don't want to have radicals in these expressions, because you can usually do more when you write them as fractional exponents. So I end up with 1/2 log 2n, and this is what they're wanting right here on number 3. Pick another one out of that bunch. Number 7 looks fun. It's all kinds of stuff going on in there. It's log base 2, the square root of m over n cubed. Okay, I'm going to start rewriting this right now. First of all, this is log, and couldn't I put this, instead of writing it under the radical, couldn't I say that's that fraction raised to the 1/2 power, right? Because first of all, let's get rid of the radical. And the reason I chose to do that first is everything's under the radical, so I kind of have to deal with it first here. Now, if you remember, that can drop out front, and this would become 1/2 of log m over n cubed. Now, when we see a fraction, we know it's the same thing as division, okay? Now, if you think about when you're dividing terms that have the same exponent, don't you subtract the exponents? Well, we're going to do something similar to that here. We're going to say, okay, there's a log rule that says I can make that, first of all, the 1/2 goes with the whole thing, right? So if I want to break apart this part inside here, it's divided, so what I can say is that's 1/2 of log 2, I need to write my 2 in there, forgot my 2. Log 2m minus log 2n cubed. Okay, now we need to distribute that 1/2 times both of those terms. So let's go ahead and do that now. That's 1/2 of log 2m minus 1/2 of log 2n cubed. All right, the first part of the expression is fine, but if you look at the last term, you see this cubed here? That can get dropped out front. And when I drop it out front, there's already a half there, so I'm going to multiply 3 times a half. And that's going to give me 1/2 log 2m minus 3 times a half would be 3/2 log 2n. And this is what they wanted you to do there. That would be totally breaking that apart into as much as I could do it. And okay, why would I want to do this in in calculus? If we're going to do some things with these functions in calculus, we want them written as simply as possible because we don't have a lot of rules, in calculus for doing some of the things that we do, like taking derivatives and taking integrals of things. So we want to write things simply. This is why we would do this. I'm going to do one of the ones, or maybe pick a couple. Problems number 9 through 11, they show you that they tell you that you've got log base 10 of 9. They're just giving you an estimation for it. This is not the exact number. It's 0.905. And they tell you log base 10 of 2 is 0.30. And what they're asking you to do here is to kind of rewrite some things in terms of these two logs. Let's start with the simple one first, okay? We'll start with number 9 first. Log base 10 of 81. All right. Now, I have the same base. How can I write 81 in terms of 9 or 2 or both? Well, how about this? Couldn't I rewrite 81 as 9 squared? Isn't it 9 squared? And the reason I'm thinking that is I've got a 9 there. Well, the log rule says if I do that, since 9 squared is 81, that 2 can come out front. So that becomes 2 log 10 of 9. But I know what log 10 of 9 is, or they've given me an estimation. It is this 0.905. So I can substitute log 10 9 with 0.905. And that ends up being, let's see, 10 and 18. It ends up being 1 point, this is accurate to 2 decimal places. 2 times 5 is 0, carrier 1, 18. It says accurate to 2 decimal places. Let's see, that should be right here. They say it's 1.90. Oh, that's because I copied it down wrong. This is supposed to be 0.95, right? So let's recalculate that. That's 2 times 0.95. Okay, so 2 times 5 is 10. Put down your 0, carrier 1. 2 times 9 is 18, and 1 makes 19. And then we had 2 decimal places, so we would put it right there. It is 1.90. I just copied down the wrong value up there. So that's what you're doing. You're rewriting the log in terms of some of the stuff that they've given you there. Let's try another one. And try to put it on this page so I don't have to recopy those logs there. Let's look at number 11. Log base 10 of the square root of 2. Okay, well that one's not so hard because we could say, well, we could write that as log base 10 of 2 to the 1/2 power because the square root of 2 is same as 2 to the 1/2 power. And now that you've got this exponent here, remember you can drop it out front, and that would become 1/2 times that log 10 of 2. But if you remember, we know what log 10 of 2 is. They gave it to us right up here. It is 0.3. So all I got to, or 0.30. All I got to do is say, what's 1/2 of 0.30? Oh, that's 0.15. So that's what you're doing there. Some of this stuff can get a little tricky. I assigned up through 13. Let's do 13 just because it looks. I can see what 13 is going to be. Okay, so for 13, you have log 10 of 8. And remember, you're trying to rewrite it in terms of log 10 of 9 is 0.95, or you can write it in terms of log 10 of 2, which is 0.30. All right, well, how can I write 8 in terms of 9 or 2? Well, here's what I could do. Isn't 8 the same thing as 2 cubed? Okay, now I've got an exponent there, that 3. That, the log rules say I can drop that out front. And so that would be 3 times log 10 of 2. But I know what log 10 of 2 is. It was over here. It was 0.30, so that's going to be 0.90. and they're having you write it out to 2 decimal places. So that's what you're doing on those. They look kind of weird, but that's all you're doing there. Let's see if we can fit something else on here. 21 asks us to express this as a logarithm of a single number of expressions. So another way of saying that is to say condense the logarithm. Write it all tight as one expression. It's kind of the opposite of what we were doing up on the problems 1 through 7 odd. So we have 5 log 4 of P plus log 4 of Q, okay? So you got to start thinking, okay, I see that I'm adding these logs, so probably I will multiply some stuff, but first, if there's a number out front, we have to remember where did that came from? Oh, it was an exponent on this P. So we got to take care of that first, because that 5 only goes with this log 4P. It doesn't go with log 4Q. That makes that first expression log 4 P to the 5th, and then I'll just copy down plus log 4Q. Now you notice we got logs of the same base. They're both base 4. So what I can do, since they're both base 4 and I'm adding those logs together, I can combine the P5th and the Q. And what the log rules say we do, not add them, we multiply them, so it just becomes P to the 5th Q. Okay, let's try another one there. I'll try to pick something that maybe uses some different rules here. Looks like we went out to all the way to 31. So let me look at 25. So we have log 2m plus log 2n plus 3. Oops, 3. All right, they're going to get a little tricky on this one. I've not really seen books do this before. First of all, I've got a lot of stuff added, so as long as it's got a log of the same base, I can put this together. So this could become log base 2, and let me just combine these two at first. That would just be, since they're added and they have the same base, we could write it as log 2 mn plus 3. Now, what they've done in the book is something that I don't notice. I've really never noticed anybody doing this before, but this book is just very rigorous, which means it really wants you to think, okay? So how can I write 3 as log base 2 of something? Well, wouldn't log base 2 of 8 equal 3? So what they're doing is they're saying, well, okay, I knew it had to be a log base 2, and I knew I wanted it to equal 3, so 2 to the 3rd power would give me 8. So what they've done is they said, hey, let me rewrite 3 as log 2 of 8. If I do that, I can continue to put these things together, because now I've got the same log with things added together, so we can just multiply the m and the n and the 8, and that's how they're getting their log 2 8 mn. That was a little tricky. I'm going to do one more. Look at, I'm going to actually backtrack a little bit and do 23 since it has subtraction in it. You've got 4 log 3 of a. First thing you got to do is take care of any numbers that are out in front. I'm going to have to go fast to fit this one on the video. So this means this 4 was with this a. That becomes log 3 a to the 4th. And then we got the subtraction sign. And then for this term over here, this 1/2 was on the b as an exponent. So it's log 3b to the 1/2 power. Now, in this book, what they do, they say, okay, if I've got b to the 1/2 power, I can rewrite that. They're just going to leave the first term the same. And they're going to say that's the same thing as log 3 square root of b. So they kind of change those out a lot, those representations of this 1/2 as a square root. And they go ahead and do that. That's why their answer is written the way it is. Now you've got 2 log 3's, and they're subtracted, so you can rewrite this as division, is what the log rule says. So it's log 3 of a to the 4th. The first term goes on top of the fraction, and the square root of b goes on the bottom of the fraction. And that would be your answer.